So hello friend, this is Kaustup Pathare and back with a new video. Welcome to our channel Making Maths Easy. So today in this video we are going to solve the sums based on Laplace transformation using first shifting theorem. I have made a previous video on the first shifting theorem. Also I made a previous videos on the Laplace transformation which you can watch in the I button. So let's start with our video. So we have the sum that show that Laplace of sine h into t raised to t by 2 into sine of square root of 3t divided by 2 is equal to square root of 3 divided by 2 multiplied by s divided by s raised to 4 plus s square plus 1. So we need to prove that LHS is equal to RHS. So first of all we will take the LHS. The left hand side is Laplace of sine of ht divided by 2 into sine of square root of 3t divided by 2. So first we will find out the Laplace of this function, but before finding the Laplace of this function, let us know the value of this parameter as sine of h t by 2. Sine of h t by 2 is nothing but a hyperbolic function, as I told you. So formula for the hyperbolic function for sine h t by 2 equal to e raised to t by 2 minus e raised to minus t by 2. This will become equal to e raised to t divided by 2 minus e raised to minus of t divided by 2 divided by 2. So this is the formula for a hyperbolic function of sine of h at, which is equal to e raised to at minus e raised to minus at divided by 2. So let us substitute this formula in this given equation and find out the answer. So Laplace of e raised to t by 2 minus e raised to minus of t by 2 divided by 2 multiply by sine of square root of 3t divided by 2, sine of square root of 3t divided by 2. So we need to multiply the sine of square root of 3t inside this function individually, and we will take this 1 by 2 constant. So this will become equal to 1 by 2 times 1 by 2 times into the Laplace of e raised to t by 2 multiply by sine of square root of 3t by 2. Okay, so this will become equal to Laplace of e raised to t by 2 into sine of square root of 3t divided by 2, and again minus the Laplace of e raised to minus t divided by 2, e raised to minus t divided by 2 into sine of square root of 3t divided by 2. So we need to find the Laplace of these both functions. We will take here Laplace symbol and then we'll close the bracket. So first of all we'll find the Laplace of this function and then we'll subtract it by this function. But before finding the Laplace, let us carefully look at the functions. These functions are in the form of first shifting property. We can use the first shifting property for solving these sums. So according to the first shifting property, we need to find the Laplace only of this function, and afterwards we will use the first shifting property. So Laplace of sine of square root of 3t divided by 2 we have to find, as sine of square root of 3t appears in the both the terms, in this term also in this term. Okay, so first of all find the Laplace of sine of square root of 3t divided by 2. So the Laplace of sine of square root of 3t divided by 2 is nothing but equal to a upon the value of a will be equal to square root of 3 divided by 2. So a upon a square plus a square, a square plus a square plus a square. So a square is nothing but equal to square of root 3 by 2. So square of root 3 by 2 is nothing but equal to 3 divided by 4. As we will take LCM, so this will become 4 times the a square, and this 4 will go in the numerator. So 3 will left remain here, and this will become 4 times square root of 3 divided by 2, and 4 times square root of 3. So 4 divided by 2 is nothing but equal to 2. So this will become equal to 2. This will become equal to 2. So 2 times square root of 3 divided by 4a square plus 3 is the Laplace of sine of square root of 3t divided by 2. So now let us apply the first shifting theorem. According to the first shifting theorem, if we compare this equation with the equation of first shifting theorem, as the first shifting theorem equation is equal to Laplace of e raised to minus of at e raised to minus of at into f of t is nothing but equal to phi of s plus a, phi of s plus a. So if we compare this equation with this first shifting equation, if we compare this equation, we will get the value of a, this value of a, this a will be equal to minus 1 by 2 in this case. So we will put a equal to minus of 1 divided by 2 in the given equation. So instead of s we have to put s plus a, instead of s we have to put s plus a as given here as phi of s plus a. So instead of this s we have to put s plus a. So s plus minus 1 by 2, s plus minus 1 by 2 we have to take. So this will become equal to s minus 1 by 2 the whole square raised to 2 plus 3. Again we need to find the Laplace of this function. So Laplace of this function, so the Laplace of this e raised to t by 2 into sine of square root of 3t divided by 2 will be equal to square 2 times square root of 3 divided by 4 times s minus 1 by 2 the whole square plus 3. We can also simplify this function. If we simplify, we will get a minus b the whole square formula we will use for simplifying the function. So let us simplify the function. This will become equal to s square plus not plus, it will be a minus b, so a square minus 2ab, so minus 2 times 1 by 2 multiplied by s, which is equal to s, and again plus 1 by 2 the whole square. 1 by 2 square is nothing but equal to 1 by 4. So I will remove this square symbol. So now we have to multiply this 4 inside the bracket. So this will become equal to 4 times s minus 4 times 4 times s square minus 4 times s and plus 4 multiplied by 1 by 4. So 4 multiplied by 1 by 4 is nothing but equal to 1, and this will go, and 1 plus 3 will be nothing equal to 4. So we can take 4 outside the bracket, we can take 4 as a constant. So I will take 4 as a constant. So this will be equal to, if I am taking the 4 as a constant, this will be s square minus s and plus 1, and 2 divided by 4 is nothing but equal to 1 by 2. So this 2 will get cancelled. Also this 4 will become equal to 2, as 2 divided by 4 equal to 1 divided by 2. So this will be root 3 divided by 2 multiplied by s square minus s plus 1. So let us look at this e raised to minus t sine of square root of 3t minus 2. Find the Laplace of this function. So for finding the Laplace of this function, we have the value of a, on comparing this with this equation, we get the value of a equal to 1 by 2. So in this case the value of a will be equal to 1 divided by 2. So let's substitute the values in the equation and find out the Laplace. So this Laplace will become equal to a upon the same we are going to use, only we have to change the instead of s we have to put s plus a. So the Laplace of this was sine of square root of 3 divided by 2 is nothing but equal to square root of 3 divided by 2 and divided by s square plus a square. So s square is nothing but equal to s square only, and a square is nothing but equal to 3 by 2 the whole square. So 3 by 2 the whole square is nothing but 3 divided by 4. So we will take the LCM, as we will multiply this 4 by this s square, and also we will take, on multiplying this with s square, we will take this 4 in the numerator. So this will become equal to 4 times square root of 3 divided by 2, and this will become equal to 4 times a square plus 3 on taking this in the numerator. So 4 times square root of 3 divided by 2 is nothing but 2 times square root of 3 on dividing 4 with 2. So now we will apply the first shifting theorem, as I found out the value of a equal to 1 by 2 on comparing with this equation e raised to at e raised to minus t by 2. So value of a, this a will be equal to 1 by 2 on comparing with this equation. So now let's substitute the value of a in the given equation as s tends to s plus a. So instead of s we will put s plus a. So 4 times s square will become equal to 4 times s plus 1 by 2 the whole square plus 3. So we will split this function as a plus b the whole square. So this will become equal to s square plus 2 times s multiplied by 1 by 2 is nothing but equal to s, and again 1 by 2 square. So 1 by 2 square is equal to 1 by 4. So now we will remove this square symbol. So now we are going to multiply this 4 inside. So this will become equal to 4s square plus 4s and plus 4 times 1 by 4. So 4 multiplied by 1 by 4 is nothing but equal to 1. And this 1 plus 3, 1 plus 3 is equal to 4. So now we can take 4 constant. So we will take 4 constant. So this will become s square plus s plus 1. So now let us perform the subtraction of two Laplace and let us prove the given equation. So subtraction of two Laplace is given as Laplace 1 by 2 times the Laplace of 1 by 2 times the Laplace of the given function will be equal to 1 by 2 times 1 by 2 times 1 by 2 times the Laplace of this function, means this is the first function, as e raised to t by 2. So 1 by 2 times Laplace of this function minus this function, as 1 by 2 is a constant, is a common function, so we can remain it outside, we can keep it outside, and this will become equal to this 2 divided by 4 become equal to 1 by 2. So we can cancel this 2, and instead of 4 we can write here as 2. So now also we can take this 2 common, and also we can take this root 3 common, because root 3 is present in both the terms. So this will be 1 and this will be equal to 1, and root 3 will come at this position. And we can also take this 2 common, because 2 is present in both the terms in the denominator. So this will become equal, this 2 will cancel, also this 2 will get cancelled, and 2 multiplied by 2 gives me equal to 4. So this 2 into 2 will become equal to 4. So this will be root 3 divided by 4. So now let us perform the cross multiplication. So for cross multiplication we have to multiply this by 1, also we have to multiply this by 1, and then we have to find out the answer. So this will be s square plus s plus 1, s square plus s plus 1 minus this minus symbol, as I am going to remove it, and I am going to put this minus symbol at this position, and minus, and s square minus s plus 1, s square minus s plus 1. So now we can open the bracket. After opening the bracket, this will become equal to minus of s square, and this minus symbol will become equal to plus. Also this plus symbol will equal to minus, become equal to minus. So this will be s square plus s square plus s plus 1, as s square is minus s square, this is minus of s square, so we can remove this s square, so s square gets cancelled. S square minus s square is equal to 0, so we can cancel the s square term. Also minus 1 and plus 1 will get cancelled, because minus 1 and plus 1 becomes equal to 0, because so we can cancel this minus 1 and plus 1. So the two terms are left here as s plus s, as s plus s is nothing but equal to 2 times s, so we can write here as 2 times s, 2 times s. So now we can take this 2 also. Now this numerator part is a single part, this numerator part is a single part, so we can take this 2 common, so bringing 2 outside the bracket, and this will be s upon s square minus s plus 1 into s square plus s plus 1, and this 2 divided by 4 is nothing but equal to 1 divided by 2, so this will become 2, and this 2 will get cancelled. Okay, so now we will perform the multiplication of this denominator. So s square minus s plus 1 multiplied by s square minus s square plus s plus 1. So this is in the form of a square minus b square. We will rearrange the terms. So this will be equal to square root of 3 divided by 2 is a constant, multiply by s divided by s square plus s plus 1 multiply by s square plus s plus 1 multiply by s square plus s minus 1. Okay, s square plus s plus 1 multiply by s square plus s minus 1. It is one and same. So we will perform the a minus b into a plus b formula as a square minus b square in the denominator at this position. Okay, so this is my a square. Let us find out the this is my a. Let us consider this as a, and let us take this 1 at this position. So this will become equal to s square plus 1 and minus s, and this will also become equal to s square plus 1 plus s. So this portion is my a and this portion is my b. Similarly, this portion is my a, s square plus 1 is my a, and minus s is my b. So this is a minus b multiplied by a plus b. So we can use the formula. So we will apply the formula as a square minus b square, as this is my a and this is my b. So let's apply the formula. So this will be equal to square root of 3 divided by 2, square root of 3 divided by 2. It's a it's a constant we have taken outside, multiply by s divided by s plus 1 the whole square, s plus 1 the whole square minus s square minus s square. So let us solve this s square plus 1 the whole square. So this is a and this is b. So a square, this will become equal to s square and square of it. So this will become equal to s raised to 4, s raised to 4, and plus 2 times s square multiplied by 1 means 2ab, 2 times s square multiplied by 1. So this will be 2s square and plus 1 square, and 1 square is nothing but equal to 1, and raised to 2 will get cancelled. So on opening the brackets, this will be s raised to 4 minus 2 times plus 2 times s square plus 1 minus s square. So 2 times s square minus s square. So s square, 1 s square will get cancelled. So this will be equal to s square. So hence we have proved the given equation, which is equal to RHS. So LHS is equal to RHS, we have proved. So if you like the video, please share, subscribe and comment on my YouTube channel Making Maths Easy for more videos related to mathematics, tricky mathematics, engineering mathematics, Vedic mathematics, 10th standard mathematics, 12th standard mathematics. Please do subscribe my channel, please hit the bell icon, so if I upload any new video you could get a video notification. So thank you for watching. Thank you guys.